Algebra 1, Lesson 109 is all about graphing what we call a system of linear inequalities, sort of like you see at the bottom there with the brace. We have y is less than negative 3x plus 1. We've learned how to graph that. It's a dotted line because it's not less than or equal, it's just less than. And then you graph it like a regular line and shade the appropriate part. It's less than, so you shade the left part. Then y is greater than, again, dotted line. X minus 2, graph the line as if it was a slope-intercept form, and then shade the appropriate part. This time it's greater than, so you're shading the greater than part. And then when you have a system, you've got some overlap. You get to enjoy what that looks like, and you see some of the shading there. A system of linear inequalities is a set of two or more linear inequalities containing two or more variables. The solutions of a system of inequalities consist of all the ordered pairs that satisfy all the linear inequalities in the system. To show all the solutions of a system of inequalities, graph the solutions of each. The solutions of the system are represented by the overlapping shaded region. Okay, I'm going to let this gentleman take it away.
You can see the solution to a set or system of linear inequalities by graphing. Click the graph to begin graphing the inequality y is less than 2x plus 1. First, graph the boundary equation y is equal to 2x plus 1. For greater than or less than inequalities, use a dashed line. Choose the point that satisfies the inequality y is less than 2x plus 1.
All right, so we're looking at which point lies within that section. So I don't think 0, 0 or 1, 3, but negative 2, 2 would be to the left. Whoop.
Try again. The point negative 2, 2 does not satisfy the inequality because 2 is not less than negative 3.
Because 2 is not less than negative 3. Substitute each x and y value to find the point that makes the inequality true. I guess 1x would be 2 plus 1. That wouldn't work either, so I guess it has to be 0, right? Right.
Since the point 0, 0 satisfies the inequality and lies below the line, shade below the line.
Okay.
These are all solutions to the inequality y is less than 2x plus 1.
Okay, so 1, 3 looked like it would work, but it probably was almost right on the line, which is not going to work, actually. Forgot that that's how we determine which part to shade. You find a ordered pair that works, and then use that side.
First, graph the boundary equation y is equal to negative x plus 3. Click the graph.
There it is.
Choose the point that satisfies the inequality.
Now I know what I'm doing. 0, 0 would be no good because it would end up saying 0 is greater than 3. So I'm getting that hint from last time now. 2 in for x would mean we end up with 1 on the right. That doesn't work. That'll be right on the line. I see what they're doing here. They're always doing the same sort of pattern. So it's got to be 4, 4, right? Negative 4 plus 3 is negative 1, which is less than 4.
Since the point 4, 4 satisfies the inequality and lies above the line, shade above the line. These are all solutions to the inequality y is greater than negative x plus 3.
If I'm correct, all of this has been reviewed for you so far. Now let's make it a system and overlap.
Drag the graph of y is greater than negative x plus 3 over the graph of y is less than 2x plus 1 to see the overlapping region that contains solutions to both inequalities.
I like that. That's a cool thing. So this is how you used to work. You had two separate. Now we make a system or set, and you see what part is going to be in both. It's just the darkest portion, isn't it? Right?
The region shaded both ways contains points that satisfy both inequalities.
All right. Here's some more practice on what I was not good at the beginning. 0, 0, I think. Ah! I thought that worked. Oh, but it's got to work for both. That's probably why it didn't work. Negative 1, 1 would be negative 2 plus 1 is... That's not going to be good. 0, 5. It's 2, 2. I should have gone all the way down. Because negative 2 plus 3 is 1, and 2 is still greater than that. Yep. Which graph represents the system? Boy, I got to think about this for a second. X plus 5, so we got to see an intercept at 5, which I do on all of them. What about an intercept at negative 4? I see that on all of them, so that didn't give them away. Slope of 1, 1. I'm only seeing that in A and C. So it can't be B because the slope on the second inequality isn't there. And then negative 3 over 1. I see it in A. And I see that one in C. But it's in A, it ends up looking like it's greater than the negative 3, and it should be less than. So I think the shading gives C away. All right. There's still hope for Mr. Otto. I'm just going to guess on this one because I don't want to take too much time. That's the one. All right. I hope you were able to follow some of this. Looks like that covers really the gist of today's lesson. You don't have, well, you could use Desmos if you want to try any of the graphing calculator ones, but I think I'm only going to be assigning you A, B, and E. Abe. How about that?